Okay, I think we can start it off. So I wish I could say good to see everybody, but I can't see. It's kind of talking to myself. Thank you everybody for joining, and it's a hot topic that we have today, and I hear that the excitement is high. By the way, as for audience, I see that we have definitely a broad audience of profiles and companies. It's quite a cross-industry audience from financial services, government, defense. We have intelligence, media, technology, telecommunication, and energy companies, and so is the people, right? Tech leaders, business leaders, CTOs, MDs, AI advisory board members, and others, and many architects and developers. So thank you so much for joining. We're going to start it off right away. Just sharing my screen. All right. All right. So, many of us are in the engine room of AI, right? We're scaling systems, we're deploying LLMs, deploying agents, pushing technical boundaries. We do a lot of stuff through the entire stack. And I hope that this webinar will give you the depth and particularly the bits and bytes and the key aspects of scaling agentic AI in the enterprise. Um, Obviously, talking to myself for 45 minutes is not easy. I'll definitely keep some time for questions, but if you have questions, drop it in the Q&A tab. We have a few people watching these, so they will surface them, and obviously I will be able to address hopefully most of them towards the end of the session. And you can also find some resources that you can check out later. I'm going to jump right into it and saying that, okay, that's what I said about the Q&A and the docs. You can access it there. Let's start with the user story just to connect the entire webinar today to a practical, real-world use case that we are working on. Okay, so it's a sunny Saturday noon in Riverside Park. A thin column of smoke rises with fire in the picnic area. Initially, naturally unnoticed by some people, but definitely captured by security cameras on light poles. A few visitors start to notice the smoke and glancing towards the source. Okay, just imagine that for something that we can start with. And here is just a quick video, just to emphasize that. By the way, did you notice the man going backwards? I'm not sure if you had enough time. I can run it one more time just for you. Yeah, and the gorilla. Did you notice the gorilla? Just joking. No gorilla. Not this time. Let's see what we are going to cover today and what's not. So what I promise you today is a very practical real-world session. No hypothetical, flashy demos and POCs that are all over the place. I'm going to speak about AI infrastructure challenges in particular. We're not going to delve deeper into privacy, security, and governance aspects that are obviously relevant in every enterprise deployment. We're going to double click on the fragmented AI infrastructure and agentic frameworks specifically, and how to scale these, of course. But I'm not going to give like a detailed breakdown of the AI stack and each of the components over there, which we will see at a very, very high level. Scaling agentic AI in the enterprise is definitely the topic. And again, integration with the enterprise systems and the stack and other legacy systems, that's not here, but it's definitely part of each and every major deployment. And we're going to wrap up with deep dive on inference and KV cache, but really beyond the buzz and understanding why KV cache at the system level is important, and also maybe what's the difference between KV cache at the LLM level and at the system level. I didn't introduce myself. My name is Ophir Zan. I'm doing AI at Vast, working with some of the most brilliant people in the world and the buyers in the world. Over the past few years, I've been deploying, working, selling, collaborating with AI leaders across a variety of industries. initially deploying LLMs and AI systems within the enterprise, mostly with regulated industries behind firewalls, so deploying LLMs on-prem and on VPC. I previously worked in a model building company that is building and training model from scratch. My background is engineering. I've been an engineer for a decade, but I'm now part of the go-to-market organization here at Vast. Definitely one of the most exciting startup companies out there with a phenomenal growth and definitely deep tech. But we're going to get to Vast later on. So that's going to be today, and we have a lot on the agenda. So I hope you'll find it insightful. All right. So let's double click on this specific parkside detection and resolution, right? We saw the use case. There was some fire, information came through the cameras. Now it needs to be analyzed, ingest, triggered, whatever. Let's speak about the key elements of this kind of use case, which is only representing many other, large-scale ingestion and ingesting processing workflows. The first one is a continuous multimodal data ingest for reasoning at scale, right? Information is coming. That can be the video streams, the metadata, geodata, and other type of modalities, which is often, by the way, stored in separate systems. So you need to know how to access and how to get this information available for further processing and inference and reasoning. Then you have a huge scale of data and vector, right? Agents are producing more information. Information is coming at scale. Think about this specific use case. It can be tens of thousands or hundreds of thousands of city cameras in that case that are streaming videos, right? We're speaking hundreds of petabytes. Vector scale can also meet quite easily billions and potentially even trillions of embeddings like embedded vectors, which we know can be a quite big of a limitation for commercial and open source models today. Think of the limitation of existing commercials and open source vectors that you're familiar with. The data can also reside in different environments, which is very typical in enterprise setups, right? Some of the data can be on-prem, some can be in cloud CSPs or neoclouds. There is no unified control plane when you think about that. So the data is coming and you need to gather data from multiple places. And if you want to create like autonomy on top of it, that can also incorporate some, ungoverned access or PII leakage and other stuff that definitely need to be taken into consideration. And the last piece is the stack misalignment, right? Enterprise, they have their systems that were deployed 40, 30 years ago. A lot of legacy IT in place for databases, for video tools, for messaging systems, for whatever it is. So when you're layering like a modern AI protocols on top of it, that can be a mess. So and it can introduce latency overhead and then like the development friction that is naturally part of this kind of interaction, right? And more. But we are all here because we understand the problem, but we also understand that this is a very, very, very noisy space. So I wish this will be a little bit more interactive. But have you heard about have you heard about the new model called Kimi K2, which is a trillion parameter open source model, which is quite brilliant. You should check the benchmarks. You should definitely try it out. Hey, how about OpenAI new ChatGPT agent? Who heard about this one? That's definitely a good one. I'm so sorry for the many startups that either gonna accelerate their development, right, with now agents available via ChatGPT, or gonna really struggle because competition is hard in our times. But wait, we have more. Grok just launched the Grok 4 and the Grok 4 Heavy, right? Oh, AutoGen. That now enables modular AI orchestration. Did you know that? And did you know that AWS and Anthropic are now offering an agentic AI marketplace? How about the meeting that Trump had, planting the seeds for endless energy for training and inferencing AI? And wait, we have more because Midjourney also released their model for video generation, which is quite cool. You probably worked with Midjourney before. And we have more. There are some reports coming up. This is all from the past month. I'm sorry about that. It's a very, very, very noisy, distracting space. And in between, in the middle of it, you have the poor chief AI officer, right? And this is just a glimpse of what a chief AI officer wakes up to. Every hour brings a new headline, new model, new benchmark drop, new agentic orchestration framework, startups pivoting into agents, the big boys creating something, new protocol is coming up, new VLM, the Qwen, the Claude, the Nemotron by NVIDIA, the new large reasoning models, the O3 and the DeepSeek, and it's before we move into the fragmented AI infrastructure in an enterprise setup, allow me maybe to add like a quick word on the risk factor that is more relevant to what probably most of you or all of you on the line are doing with AI, the consumer part of it, and what enterprises are doing, right? We are consumers. I'm using AI heavily. I have different type of agents that are feeding me with information. I'm using all system. Actually going to see what I've used just to create those slides at the end. But in the consumer, the risk factor is a relatively low risk, right? You break things, nothing happened, and you can do rapid growth, as we saw. Mistakes, okay. And the infrastructure is also flexible because we have a latency tolerant. So Notions and ChatGPT, and I'm not going to name them, hundreds of other consumer tools are booming. On the enterprise front, there is a high risk, also high potential, but definitely slower rollout. For those who think, by the way, enterprises are not getting to production, they are absolutely wrong or hallucinating. I've personally spoke with corporates that already have like more than 100 use cases in production. Some of them are serving 200,000 employees within the corporate. So that's absolutely not the case. What used to be 2023 and 2024 has changed over time, and much more investment, much more structure into these processes. The infra, obviously, in the enterprise is also challenging. And with that, I want to jump right deep into the enterprise setup, right? Look at this slide. I'll give you a moment. This fragmented AI infrastructure is the norm. That's the norm, right? As agentic AI now growing, system complexity increases, and it drives the need to integrate databases and object stores and vector engines. And this all shift into agentic AI moment that is already all over around us, right? Is putting more architectural bottlenecks, and we will speak about them, because stitching together components and tools that now needs to be governed. It's all here, right? Audit, tune, integrate, maintain, govern, and scale. Yeah, that definitely not an easy task for the builders. So in the AI and agentic AI context, I think that fragmented infrastructure becomes even a bigger, greater challenge. But I think you already know that because you're here. So let's double click on some of the agentic frameworks, which we're going to use this information later on. Okay, I want to make sure that we're aligned on what agentic frameworks are, why do they relevant, etc. And as I said, we have plenty of content to cover, some kind of moving quickly, but feel free to shoot some questions if you have in the chat. Popular agentic frameworks. And I believe that by now, some of you already built and played with these. I would say probably the most popular one is the LLM as routers, right? When you use an LLM to direct an input and route it to the relevant task, to the relevant agent, to the suitable agent, to the tools that it needs to use, etc. It's like a traffic controller, essentially. It's pretty static. It's using LLM as a traffic controller, but it's pretty static. There is nothing dynamic in the planning of this action space, right? I'm definitely assuming some baseline understanding of some of the terms and how agentic frameworks works. And if you're a little bit behind on that, first, my sincere apologies. Secondly, I'm happy to bring you up to speed and sharing some information after the webinar. Agent trees, right? Decomposes the complex problems into smaller and more manageable tasks that each handle basically like a dedicated agent, essentially. Parallel execution, which is good, right? We know that's important. And essentially within an agent tree orchestration, you have like each node can like create child agents that essentially enabling the scale for multi-step reasoning, right? Multi-step, and you have multiple iterations. On a side note, I would say that some of the tasks that enterprises have today cannot be addressed using state-of-the-art RAG, right? Or LLMs as planners, like LLM that is doing some planning and reasoning because of reliability factor that is really challenging. And therefore, sometimes we need more control over the action space and over the decisions that agents are doing. So the autonomy, there's like a trade-off, right, between how much autonomy, accuracy, reliability, obviously other factors like the cost, and the list goes on all the way to energy, right, energy consumption. React, reasoning in act, is definitely a popular one, where agent can think and agent can do. Right? Let's take a prompt for as an example. Maybe, can I get a refund for product that I purchased, ABC product, right? So the reasoning piece will be like, let's understand the intent and determine the necessary checks that needs to be done. Then the action will be like, look for the refund policy, and then go and retrieve information about orders history, and then maybe confirm that the product eligibility for being refunded, right? And then you need to reason again. So reason and act. And now you reason about decision and need to get all this information together and decide what you're going to do with that. I'm not going to delve too deep into, obviously, these are just some of the popular, but there are more. Tree of thoughts. I think this one is very interesting because essentially it's like probably most similar to the way we think and deal with complex problems that we need to address. There are multiple reasoning paths, right? There is no like one solution to a complex problem. And I'm sorry that the word complex is not clearly defined, but assume complex, something that will be hard for a human or even a group of humans or researchers to handle, to complete. If you think of as an example in that space, it can be something like maybe investment strategy, right? When you prompt what is the best investment strategy for a mid-risk profile in 2025. So multiple thoughts, invest in this, diversify that, include some real estate, include some other stuff, bonds or whatever. Then evaluate those thoughts, right? Score them, understand them, the trend, the risk, etc. You can then expand just to get further, stronger thoughts that are more grounded into data. So you do some retrieval and you get some information and you get some, geographic diversification, etc. And then you can conclude. So this is like these specific frameworks. A quick note on orchestration, like agentic orchestration frameworks, right? As you can see, there are some logos on that slide that are, stuff like AutoGen Studio and LangGraph and Agent Ops, CrewAI, etc. Orchestration frameworks coordinate those multi-step tasks and the tool selection and the role-based agent behavior on top of whatever architecture you choose. So sometimes there is some confusion. What I'm presenting here on the screen is the agentic frameworks, and these are not the agentic orchestration frameworks, which I know can be a little bit confusing sometimes. I wish we had a little bit more time, but we will probably, if I needed to choose like an extra topic, I would choose reflection in agentic workflows, which is quite interesting, but being cautious of time and definitely want to keep some time for questions, I'm going to skip this one. So I want to go back to our example, right? I want to go back to the video ingestion and multimodal agentic AI use cases that we have and connecting everything into VAST. So let's get a sense. If I needed just, to request a random person, tell me some of the, components typical components that are involved in this detection and resolution use case, what would you say? Can be many, right? It can be the edge, the cameras, storage, I don't know, video systems, vectors, LLM, VLM. VLM stands for Vision Language Model, okay? But it can also be like different types of agents, right? It can be an agent that is doing the ingest. It can be an agent that is taking information and then creating some inference on top, using some tools, some memory, some multi-step, some orchestration frameworks that we've mentioned before. And then even the results can trigger some systems, right? Because when you think about a resolution like that, and I know that I didn't spend much time on the time, like how a typical resolution will look like, you can think about if I have an agent that can streamline this process, then I can maybe, have some time, like cutting response time from, I think in the example, it was 15 minutes or 13 minutes-ish to 3 minutes, right? Leading to, that can easily lead to increased demand, increased damage, and injuries in that specific public safety use case. And obviously there are many capabilities that needs to be incorporated. So what I'm going to do next is I'm going to delve again into this agentic pipeline that is being deployed in enterprise setup. And just to give some extra context, I want you to look at what happened at a very, very high level and what components are involved, right? So we have the smoke that is now being detected by those cameras, information coming from the camera, being stored. We trigger some functions. We do some computer vision, right? We then maybe send it to an ingest agent that is doing like vision language model, creating a textual summary of the scene, what's actually happening. And that should be updating over time. These are live continuous streams. Then we have clips that are now being captioned, right? We need to understand what's actually happening. We're going to use some reasoning models. I'm going to delve into that in a second, so don't worry. And obviously some APIs, right? Additional tools I can think of, tracking some information about where people came from, what was in this specific area 5 minutes before the fire started, et cetera, et cetera. And obviously vectors and everything is involved here to retrieve that information. And we can then take some actions, and actions can be very similar to what you will do as a human. But I don't know, I can think about a report that is automatically being generated and being sent to the relevant authorities, a call that is being made to the 911 operator and checking information that is coming from multiple cameras or from other calls that being made. And we can basically create like a much more streamlined process. But nice in theory, much more complex in reality, right? If we need to look at a ingestion and multimodal agentic AI pipeline like this one, and I wanna emphasize this is a very, very high level, right? We can go much more granular than what you're seeing on the screen, but essentially at the bottom line, you have an ingestion pipeline taking all of this multimodal information, but mostly the videos, running them through a pipeline to do whatever it needs to do, and then starting to detect and investigate and take actions, and then investigate further. And then you need to have like a certain level of accuracy or trust in the response. So how those agents should be built and what kind of information am I sending to the VLM in that specific case, right? So this is just like a joint blueprint, and there are some NVIDIA components as part of the NVIDIA VSS, video search and summarization, that are planted in this slide. But think about it, it's like, and what do I do with the videos, and how do I maintain good enough latency, right? And throughput for a use case that is so time sensitive and dealing essentially with humans' life in that specific case. So the use cases across the enterprise, and I was thinking about, should I actually put a slide and name some large scale agentic use cases within the enterprise? I just started to put it together and realized that I wouldn't say hundreds, but it took me 1 hour to put 30 solid agentic AI end-to-end use cases that I've seen within enterprises across banking and hedge funds, technology, retail, actually, telecommunication, healthcare, life science, and other industries. So I'm pretty sure that for you that are on the line, you're probably already dealing and already mapped out those use cases that needs to be addressed. And you start to realize that for scaling that, it's an infra problem. It's not only the application or the LLM I'm going to use or doing some fine tuning to an LLM and then deploy it privately. It's more complex than that because you need a unified platform. So what we saw before was a fragmented platform. What I'm going to introduce quickly is a unified AI platform, data platform, right? Sorry, I skipped one of the most important slides, just this one. Okay, so you know what, just quick check if there is some pressing message or something I need to address. I don't see any specific message or note from the organizers, so I believe we're good. Let's just move on. I hope you're enjoying so far. I can tell you that speaking to myself for half an hour and hearing no feedback, seeing no smiles, seeing no angry people or great questions or annoying questions is really distracting me. I need to do something about that. I wish I could put all of you on stage so that we can speak openly, but that's not the setup here. So I'm just going to move on with my frustration. All right. It's weird. All right. Unified AI data platform. Such a big buzzword, right? What does that mean? I promise to pick up on this one. But let's speak about the agents just for a sec, right? What we saw, what I saw, is that agents that are much more focused in their approach, that has fewer tools, that are specific, right, are usually delivering faster and more reliably. And it's a complexity trap. We think more tools, right? Let's give the agent whatever it needs, feed it with everything, you'll get better agent. Not the case. And if you even remember the agent architectures that I demonstrated, right? Choosing the right agent architecture matters probably more than choosing the right model and the right model size, which can be surprising. The best agents do one thing exceptionally well. You can call them task-specific agents. And while memory is important, and it is important, we're going to speak about it today, perfectioning the memory isn't, right? Complex knowledge graphs and vector stores and state management. And you know what? I have a disclaimer. I don't have an exclamation mark on everything that I'm saying. This may change soon, but at the moment, with where we are in deploying agentic AI workflows within the enterprise, perfectioning memory is not the most important thing. There are so many other aspects in the stack that needs to be optimized and prioritized. And autonomy, right? We spoke about it. Yeah, for sure. Do autonomy. Give the agent full end-to-end autonomy. But then you need to deal with errors, edge cases, fallbacks, and what else? Right? I don't think that human in the loop is a bad word. Human in the loop for some critical agentic flows is probably a good idea, at least until you get the confidence level that you need to get. Speaking about confidence, I think it was OpenAI that demonstrated like an agentic workflow. It was like a reasoning or deep research step that took like 350 steps and called 30 different tools. There is one word I really want you to remember in regards to agents: traceability, right? Traceability of agents across the action space is really important. When I'm saying the action space, think about a chess game where in each and every step you have like different moves that you can choose. So these are the paths, right? Execution paths. And essentially agent can choose each and every one of them, or can even choose one and then go back and start another one, etc. So enabling this traceability of agent decision, including the memory states, including the tools that has been used by the agent, including the execution paths so that you can reverse back and see, because essentially if I'm an investment broker and I'm relying my research essentially on something that the agent did, calling those 30 different tools and executing 350 steps, how can I trust the number? It's all related to trustworthiness, right? How can I trust the number if I cannot understand what the agent actually did. So with all the magic, and there is magic in autonomously reason and act, taking action on my behalf, digital worker, right? That's what they are. That's what we all call them. Every enterprise will have thousands of agents running digital workers doing all of our stuff. And don't get me wrong, I'm already using some of them, but for tasks that are, I don't know, create a pre-meeting brief for my meetings tomorrow. Not that bad as suggesting I don't know, a buy or sell side, agent in a bank to make a purchase for $15 million. Last point that I want to emphasize here is the end-to-end throughput and latency. It is a real requirement, so working on improving them, it's very much related to the fragmented infrastructure, and it's hard. It's hard to track when you have so many systems that needs to be maintained to understand how the throughput and how the latency will look like. I'll say a note here, about SLMs, small language models. We're speaking like 3 billion, 1 billion model parameters, 7 billion at max, but smaller models that are even aimed to be potentially deployed on edge devices. They can definitely leverage to get like faster, cheaper and more scalable agentic AI. And I think it's now like a big discussion in the AI community, especially for repetitive, I'll say tool-driven tasks. So SLM is definitely something to look at. In my previous company, a company that is building and training model, SLM was like the North Star, because we realized that small model will be key. Obviously, if you're chasing AGI, you cannot avoid like a trillion plus parameters model. With that, let's see what is VAST AI OS, AI operating system. So just a segue before I'm showing the AS, right? This is the situation we had before, but just imagine, just for a sec, that you will have a platform that will allow you to orchestrate the AI stack from bare metal to the application. Now, I know it's a lot, right? Like managing the access to the hardware and the storage. And then, you know what, why giving, let's just jump into the slide, into what the VAST AI OS is, okay? Before we even delve into that, I want you to think in your head as maybe an agent-ready platform. An agent-ready platform that has all the layers that need to be managed and orchestrated, deployed and scaled for large-scale agentic AI deployments. And it's not complete, and it's in process. But as far as I see, from what we're seeing in the field, managing the infrastructure for AI and orchestrating the stack is really, really more important than selecting the right LLM to fulfill that vision at scale. And if I need to break into the components, and obviously this is not a deep dive into each and every component of us, but at a very high level, right? The data store is where it all started, with an amazing vision and execution by a phenomenal team of builders at VAST, led by Brennan, our founder and CEO, which basically built and redefined the infrastructure and the architecture for storage from scratch. What brought the company to over 1 billion in annual software revenue, and continue to grow each and every year like crazy. So that's definitely exciting. And on top of that, it just started there, right? They added the layers of the database for the vectors and the events and managing catalogs and everything related to that data engine, which is basically the connection into this application and how to serve them at large scale. I'm trying to give the background, but not going too deep, because I don't want to double click on the AIOS, and definitely can share some valuable resources after. But I would say that vectors, event functions and triggers, containers, obviously, that can be deployed. We spoke about those different environments, right, where data can reside in an on-prem or neo cloud or other spaces. So how do you manage this orchestration with a data space that can basically allow you to surface everything into one layer and accessing all your data for these agentic workflows at scale. A key value cache accelerator, which are very much related to real-time inferencing at scale, and we're going to elaborate on that quickly. Insight Engine, which is our tool for fast retrieval and embedding, obviously, and basically like a retrieval pipeline end-to-end for any kind of modality, any kind of data at scale that is backed by everything that is sitting underneath and bringing those values. And we see that as a key, missing piece in an enterprise setup, even for RAG use cases, not even speaking about, agentic workflows. And by the way, we used to deploy RAG within the enterprise, but it usually was to a certain scale, right? 6 million documents, 10 million documents. Then what's happening when you have like tens of thousands? What's happening when you have billions of embedded vectors? How can you support that scale in a sufficient latency? So the stack is definitely broken, and I know there is so many approaches into RAG and agentic RAG, and I'm not going to list and dive into these on what you're going to do what you can potentially do to resolve some of these hurdles. Enterprises are still pretty much struggling with use cases that are simple retrieval question answering for complex questions with documents that cannot be easily analyzed, or like put simply into a vector and then running a search on them to retrieve the relevant information. It's more art than a science, but also the science piece is really lacking a few major building blocks. We can dive on that in a different session. On the agentic front, Fast is basically building an agent and model orchestration framework. Now, there are many out there, right? But what we're going to do here is basically open it to any other agentic orchestration framework so that you can basically build in an easy drag and drop environment your agentic pipelines so that you can support them. And, even if you take the public safety example that I shared, there are about probably 30 or 40 agents that were mapped out that can easily be built on top of the platform while managing the full orchestration and the stack. And guys, just to be clear, we're speaking like first of their kind problems worldwide. It's not something that organization has yet fulfilled, scaled, and repeated over time. But when you are spearheading, right, and at the forefront of this domain, dealing with these kind of problems, with this kind of scale, besides the fact that it's fascinating, I think that you're also learning a lot, and learning is probably the biggest return that we have, right? All of us in the engine room. So I hope you're enjoying it as much as I am. From here, I want to move on to KV Cache. Why? Because I'm sick of the noise around KV Cache. Because I'm tired of it, right? Inference and KV Cache, system level KV Cache, LLM KV Cache. At its core, I see that we're good on time. Probably I'm going to wrap it up in 5 minutes. We'll have time for questions. At its core, the goal of inference, right, is to maximize the throughput, the queries per second throughput, and to minimize the latency, seconds or milliseconds per token, which are both directly the end user experience, right? It's the experience that you have with an AI system, whatever it is. The throughput is the work that is being done over time, right? Usually measured, as I said, queries per second. It can be tokens per second. And the latency is how long a single task takes. And usually when you measure latency, it can be like latency related to the system that you've built, but also latency related to the hardware and the GPUs that you have, incorporating all of it together, measuring all of that. It can be isolated from whatever deployment you want to scale in the enterprise. And inference has a lot of variables involved. I want to be clear, right? It's not just KV cache. It has many variables, especially in a fragmented stack. Production inference and the race for super intelligence across the entire stack is definitely a hot topic in the community. Maybe just to be clear, and I'm going to give like a very concrete examples about LLM and inference, but transformer models. To this audience, I don't need to explain what a transformer is, right? Transformer LLMs have built-in KV cache at the token level, right? And it's used to accelerate inference. So I know from a few chats that I had with a few executives from corporates I'm working with, they were particularly curious about this aspect, right? What are the implications? What are the financial implications? Why KV cache at the LLM level and the system level are so important? When you want to scale those enterprise large-scale deployments, the inference demands go beyond token level caching into system level caching, basically managing the K and the V's, right? The keys and the values across different layers of the stack. And our smart co-founder and CTO, Alon Chorev, told me the following. He said, three things really matter for inference. One is the resilience and the uptime. The second bit is the system level KV cache, obviously. And the third bit is the access to data sources during inference time. So resilience and uptime is pretty clear, right? You're working, I think DeepSeek, when DeepSeek came along, they showed the capacity and the ability for faster training GPU cycles for storage capacity. So resilience and uptime for a system is definitely clear why it's coming as a key component for inference. The third bit of the access. Let me take an example even of one of the agents that we have here. Agents need to do an action based on the inference results after investigating the specific scene that we've saw, right? In a fire in the park, right? They need to look at the videos, but they also need other sources, right? They need other sources, they need other API, other systems, other databases. So I hope you follow. I'm on the verge of speaking to myself for 46 minutes. I'm just waiting to cut it off and hopefully bringing all of you on stage. But I hope you're good so far. There are some examples here, and I'm happy to share some white papers that are really fascinating about what Vast is doing with KV cache specifically. But there are some critical and beautiful improvements of time to first token, TTFT, that we're doing. And there is also a fascinating integration. I'll speak about the integration with Dynamo in a second. Numbers, right? CFOs, business leaders, if you're not asleep up to this point, let me wake you up with some millions of dollars, okay? Why should any CFO care about KV caching? Let's take a model that you all know, GPT-4.1, the pricing. I took it basically from the website, right? You can see the input price is $2 per million tokens. The output price is $8 per million tokens. And the cached input, we'll speak about cache that is like being used after the first call, the first iteration, is 0.5 per million tokens. Now let's take an example, right? And it's all here on the screen, so I hope you can follow. Let's take a chat agent, never heard of this before, that uses 50,000 tokens, right, as input for a RAG prompt. Think of 50,000 tokens as a 75 word page length, I don't know, font 12, something like that, between 75 to 100. That's like the length of the input. And the output is relatively small, right? It generates like a 1,000 output token, which is a 1.5 pages of Word document. Calculation. The first turn, right, 0.1108, because the input is 0.1 and the output is 0.008. Then you have the following turn, right? Now with the cache reuse, and look at the cache reuse, it's 0.033 for the first turn. If you are not using KV cache in that example, like the potential saving here, just for this example, for a very typical 50,000 token RAG prompt for question answering using a chat agent is 70% for the call. Multiply this by thousands, or I don't know how many daily interactions they have for an application. It can be an application that is not necessarily customer facing, but reps are using. And the CFO suddenly really cares a lot about KV caching. Okay, so just wanted to ground it a little bit with some real numbers so that you understand this topic is more than just a bluff, just like a fluff. I'm going to run through the next slide, not going to delve deeper, but I do want you, the audience, to know that VAST is working very closely on KVCast support via Dynamo using the brilliant NVIDIA team and the technical product owners that are close partners of VAST. It basically, in one line, putting the VAST accelerated storage into one of the tiers within NVIDIA GPUs, and providing this like continuous scalable storage pool of KV cache for KVs that are not stored within it's called like G1, the GPU, G2, the CPU, and G3, the local flash, the NVMe storage. So there's a lot going on. If you want to learn more about this one, it's a work in progress, but definitely important for TT time to first token and the pre-fill stage, but we're not going to delve, just being cautious of time, into this one specifically. Just checking the notes section. Okay, we'll get to it quickly. I also had a slide about LM Cache because we also work on an integration with LM Cache, the open source. I just realized, sorry, that I didn't pull out those points, but I can share it after. And yes, got to almost the last slide. So we're all using these tools. We're all dealing with the same problems. Enterprise setups are complex for the many, many reasons that I've listed today. I hope you can resonate with some of these. These are obviously not all the aspects that needs to be managed, especially in regulated industries, setups that needs to be governed and secured and access and many other aspects that we at VAST are dealing with for every deployment we're involved in. I think that if I have one note maybe to add before we wrap it up, is the question about services. Like, the services essential for large scale agentic AI deployment in the enterprise? And I think that the answer is yes, right? Because you have legacy integrations with ERPs and with CRMs and data warehouses and whatever. And you have very specific use cases that sometimes you need to tailor and optimize and fine tune an agent and optimize a pipeline or a workflow, something that we're definitely dealing with. Change management, right, of people, of processes, of reliability, compliance, all those aspects. I know it's not that fun to speak about that specific aspect, but I think that we're all a little bit, product biased in regards to, hey, platform, but services we don't need. I think it's definitely part of every aspect of scaling enterprise AI deployments and agentic deployments. And I'm very happy that more and more companies are established in that front and getting the skills to do it right and to actually help enterprise deploy faster and bigger, because bigger is the key. So I use many tools to put together those slides. Here is a list, but I hope you find it interesting, and definitely don't be a stranger. Here are my contact details. I'm with VAST. Definitely love what I'm doing. Definitely love working with very, very smart people around me. Thank you so much for taking the time, and let's jump into some Q&A. And it's still silent here. Okay. Marketing, Mendy, if you're on the line, I can't see the questions. I'm not sure. I think that Jesse is here as well. So my colleague Jesse is on the line, probably address some of the questions, but okay. How does VAST Data Platform help facilitate modality alignment and synchronization at scale, for example, in a public safety use case, show you would need to have a real-time sensor to video alignment to support emergency responses or report creation. Okay, several aspects from my perspective to this. Handling different modalities. So VAS is definitely integrating with state-of-the-art tools to basically extract data. Companies like Unstructured IO, which is a partner of VAST, to handle and to understand those different modalities that are coming through the system, right? You also have video analytics integration partners. So for that specific use case, VAST is handling the end-to-end platform, whereas different aspects of the pipeline, like the one mentioned here specifically in that example, for the time sensor and the video alignment and support for emergency responses. So the support for emergency responses is coming from the stack that VAS is providing to support that scale, to support the end-to-end pipeline to flow. And if you recall, the pipeline that I demonstrated with the ingest piece and then the agentic workflows on top, and whereas other complement, right, partners, tools, ecosystem that needs to be integrated, we integrate them into a solution like that. And there is a lot of work. Don't get me wrong; it's not like plug and play. Sometimes choosing the right partner, choosing the right integration, making sure the partner know how to utilize the components within the vast AI OS. But it's usually well received, because I think it's the first company to introduce something that is working and working at scale and already proved on some of the biggest clusters in the world. So I hope it addresses the question. About scaling, operation, and maintainability of inferencing use cases. Could you elaborate why vast data is a platform of choice? Absolutely. Jess, if you're on the line, would you like to address the scaling aspect? I think it will be nice for the audience to hear another voice that can chime in. Not sure if I should bring you to stage or. Yeah, Jess, you need to go on stage and join me here because I'm speaking to myself and it's hard. Okay, if Jesse is not able to chime in, I'm happy to address this one. Fast is all about scaling, right? We've built the infrastructure end to end, started with storage, added with database and the data engine to support those workloads. It's basically the vast pitch, this question. Maintainability, observability, easy scaling. We're using a set of components, compute nodes and data nodes that can be scaled and added horizontally and support any kind of workloads without any limitation of data and IOPS. I think I'm just wondering if I should maybe bring a slide and give like a further deeper brief on VAST. I'm not just sure it's the best timing to do that, but whoever sent that question, please, my contact details is on the screen, and if you need, I can send them after, and I will send you a more detailed deep dive into how VAST actually support and obtain and maintain inference at scale. Inference is actually, from my perspective, is touching all the stack that we've discussed, right? Managing the infrastructure is basically allowing us also to optimize the inference. It's very much touching the vector scale that we are introducing that supports trillions of embedded vectors, that triggers and functions, the ability to deploy Kubernetes within any environment, the vast operator that can manage those GPUs more effectively and utilizing them to the max. And then, of course, the tools that are relying on the infrastructure and the secured setup end-to-end that we're providing to customers. but we have many proof points to share why Vast is actually built for that. Mandy, can we allow people to go on stage maybe? Okay, we're almost at the top of the hour. I wish I could see everybody, but I hope you find it interesting, and if you want to learn more about what Vast is doing in the AI era, it's basically building the infrastructure to manage this stack end to end. It's fascinating, it's big, it's challenging. We're learning a lot, and luckily we're learning together with very passionate, ambitious, and creative customers that are working on projects like the one that you saw here. There is much more depth to each and every aspect that we've discussed here, and Vas definitely have the experts to delve deeper on that. So I appreciate your time, and hope to catch up soon. See you in the field.